Hi everybody. So this will be the first part of the Analytic Geometry booklet. Here we'll look at using graphs to help us solve equations, and you already know how to do this. We explored this way back in the beginning of the year in September when we were solving using the graphing method, two straight lines in linear algebra. We had that whole unit at the start. So you've seen this before, but we haven't really, cranked it up a notch. And so here we're going to crank it up a little bit. Here we'll look at, recalling what some of our graphs look like, and also how to use graphs to help us solve our equations. In the next video, we'll look at how to use graphs to help us manage inequalities, which, is pretty interesting because we wind up altering the dimensions of our reality. Yeah. Okay, we'll get there. It's going to be awesome. Okay, so let's first of all just review a little bit about how to, just use general graphs in order to solve. This goes back to the beginning of the year. Okay, so let's say I ask you to find the unique solution, the x and y value that solves for y is equal to 2x minus 1 and then x plus y equals 5. This goes back to early September. Right? If you recall, one of the ways we could solve this was by graphing these out. And so this is a straight line, and that is a straight line. So let's see what that looks like. Right, we know how to read the equation of a line. There's your slope, mx plus b, so my b value is minus 1. Slope, recall, is rise over 1, so there's my b value of negative 1, and I rise 2 and run 1, right, and I create that little step system. And so that's what the graph of that equation looks like. And remember what a graph means, right? A graph is a series of infinitesimally small points grouped so close together that you can't see the spaces in between them. There are spaces, but you can't see them, and so that's why we draw the line. And so over here, for the other one, we could rearrange it in y equals mx plus b format. It's fine. But I think this one is just easier to use by table of values. So let's have a look at that. Right, so here I just wrote up a table of values, x and y values that balance this equation. So two numbers that add to 5, right? 0, 5, 5, 0, 3, 2, 1, and 4. Right, those are x and y points, which you can plot on the graph. I know it's incredibly straight, awesome line, I know. Right, but we see the two lines, and we see where they cross. And that point where they cross is the xy value that balances both this equation and that equation. And we call it the solution point, right? So that's your solution. X is equal to 2 and y is equal to 3. So we've already seen how to make this happen. Now, I could change this idea slightly and ask you to solve a simple algebra equation. So let's just keep this in mind. I may ask you to scroll back to this answer in a moment. But let's just have a look at a slightly different version of this question, and we'll kind of tear it to pieces using this method. All right, here's a slightly different version of pretty much the same question. It doesn't even look like the same. I don't know what you're talking about. I know, but just check this out, right? Because of COVID, we weren't able to use the graphing calculator video that I wanted to show you. It's not a video, it's the graphing calculators. Because the graphing calculator actually can make algebra obsolete. It's kind of a neat little trick. So this is how it works. We know that both of these guys are equal to each other, so I'm going to make them both equal to another variable. I'm going to introduce a second variable, the variable y, maybe? Right, they're both equal to the same thing, right? We've got to, that's what the equal sign means. So I'm introducing a second variable. And I'm going to take this equation and write it out, and I'm going to take that equation and write it out. Look familiar? Right? Y is equal to 2x minus 1, and y is equal to negative x plus 5. If I move the x around, that x plus y equals 5. That was just like our last two questions. So let's just solve this by regular algebra and see if we can get an answer. Don't worry about this line down below, but let's see if we can solve that by regular algebra. Let me erase that. And so, right, I'm going to add 1. I'm going to add an x, and I get 3x is equal to 6, so x is equal to 2. Scroll back a bit in the video, and tell me what the x value was of the intersection of these two equations. Yeah, if you recall, the answer was x is equal to 2 and y is equal to 3. X is equal to 2. X is equal to 2. Okay, so here are some of our graph shapes that we need to remember, because we're going to be using the graphs to help us solve our equations, right? So, you know, if you remember parabola graphs, x squared, absolute value graphs, right? The slopes are 1 and -1. Here we have the 1, 3, 5 method over here with parabolas. So it's curved, and these are straight lines. We have our square root graphs. Remember what happens with the negative signs, the backwards and forwards and ups and downs. And then we have our reciprocal graphs. And those are our main, what I would call our vertex graphs of the unit. Now there are other ones we talked about last unit. For now, this is good enough for us to move forward on. So don't forget how the vertex works. I'll just remind you of that. Now the vertex kind of works the same in all of them. So I'll just do a vertex of, say, an absolute value graph. Let's see what that looks like. All right, so here's like an equation, y is equal to negative absolute value of x plus 2 plus 3. Remember what the negative does? Yeah, it makes it go down. So it's a downwards V graph, right? It's the absolute value graph. The negative makes it go down, so it's a downward shape. And the vertex, right, is the opposite of that number and the same as that number. We talked about it all last unit. I mean, that was probably one of the most common things we did every day almost of that last unit. So my vertex is going to be -2, +3, and it's going to be a downwards facing V graph. So here's a quick sketch of what it would look like. Something like that, right? We have a vertex of -2, +3, so -2, +3. The slopes are 1, so boom, boom. We could find our x-intercepts pretty much no problem. So just a quick reminder of how these graphs work. So let's see what happens when I add this idea of analytic geometry. Oh, it's going to be awesome. All right, so I just want to have a look at the question like this. We can solve it algebraically. Let's do that, and then let's solve it using graphs, because that's what we're really talking about. So let's just do the algebra. Remember, when it's absolute value, you have to separate the two into two separate equations. So let's do that. We separate it into two equations, one for the +3 and one for the -3, because absolute value makes everything positive. So I can figure out what makes this +3, then I'll get 3. And if I can figure out what makes this -3, like that's what this question is all about, then when I do the absolute value, I get 3, right? Let's review. So let's solve it. Okay, so I got 2 and -4, two separate answers. So let's have a look at how we can do this using analytic geometry. This is what the whole course is designed to get you to be able to do this. And I'm so choked that we have this COVID right now and we can't do this in class because this is the overarching idea of the entire course, is to be able to do this job either by algebra and or by graphing, right? It just makes the sum of the parts, the whole, greater than just the sum of the parts. So let's do it by graphing. We know what our answers are, 2 and -4. Okay, so here's the t-chart, right? So set a t-chart. So we want to split this into two separate equations, one for the left side and one for the right side. So I have y equals that, and then I have y equals that. Okay, let's have a look, right? So y equals the left side, so absolute value of x plus 1, right? That has a vertex and all that. And then I have y is equal to 3. And I want to graph these, right? So you got to remember the vertexes and all that sort of stuff. So let's have a look at that. Right, so here's your absolute value graph, right? It has a vertex of -1, 0, right? It's +0, we don't show the 0. I don't go around saying I got $5 plus $0 in my wallet. We don't show the 0. So there's my vertex of -1, 0. Boom. And then it's got the slopes of 1 and the slopes of -1 over there. And so that's our first graph. Our second graph, y is equal to 3. Well, that's just a flat line. It has no slope, and it has a y-intercept of 3. So what does that look like? 0 slope means it's flat, and with a y-intercept of 3. You can think of it like this if you like. Y is equal to 0x plus 3. So 0 slope, right? 0 rise, 1 run, whatever, right? So that's that. And so that produces a flat line. And just like in our original stuff, we find out where they cross. Okay. Remember our answers was, what was it? 2 and -4. Let's see if this turns out to be that way. Okay, so there's where they cross, right? -4, 3, and 2, 3. We know that the y values have to be equal to 3 because we drew them y is equal to 3. So the y values are 3. What are the x values? Well, the x values are 2 and -4. Those were my original answers. Right, there you go. If you scroll back a couple of minutes, you'll see that those are the answers that we had when we solved it by algebra. And that's the answers that we get from doing analytic geometry. So all you do is you split this into two equations. One equation for the left side, one equation for the right side. Graph them both. There you go. Nice. This is really, really, really helpful, especially when you have a graphing calculator, because you can split things apart. And if you want, you can do algebra here, move things around, and then graph what you want there. So I'll do one more example where I move it around, and we'll see if we still get the same answer. Okay, let's check it out. All right, so same question. Let's do a little couple tricks. I'm going to move the 3 to the other side. So I'm going to minus 3 to the other side. Right, no problem, right? Just move the 3 minus both sides as usual. Now I can still split this apart, graph it, and I'll still get the same answers for my x values, because that's all we really care about. So let's see that. All right, so I've split it off into its two separate equations, and now I just have to graph them out. The first one is, it's an absolute value graph. It has a vertex of -1, -3. So let's see. Okay, so there's the absolute value graph, and then y equals 0. That's just the x-axis. Do you guys see it? You see what's going on? Check out where they cross. And you only really need to care about the x values, right? So did we get the same answer? Yeah, got the same answer. So that's why this is really, really powerful, because you can really play around with this and get it to a situation where you have easy graphs to work with, and you can almost see the answer in your mind's eye. And so when I'm doing these questions with you on the overhead or here on the YouTube, that's what I'm doing in my mind's eye. I'm looking at the graph in my imagination and seeing where things cross, and I get my answers. And I don't have to do algebra. I just have to be able to know what the graphs look like. And I can do this job in my mind. So now I get paid to do this every day, all day, and I've been doing it for 21 years. So I better be pretty good at it. But it's not a situation that's impossible to learn. In fact, it's really part of your curriculum here. We start you off with some easy examples, and then we get into some pretty funky stuff where we start rearranging the dimensionality of our math world. And that's what we'll talk about next lesson. Okay, guys? So I'm going to sign off, and we'll talk about the next stuff, and we'll get into the booklet then. Ciao.